Okay, I want to find the force needed to just touch the pad at C, and this distance is 10 millimeters. And our spring constant is 5 newtons per meter. Let's do it this way. So if I draw a free body diagram here, then I definitely have a force in this direction here pushing down. I'm going to guess my A force pushes up and my B force pushes up. I just will call this A and B. Okay, so if I sum moments about B, this equals 0, I end up with minus A times 50 millimeters minus F times 50 millimeters. So these cancel. I get F equals minus A. Well, this means I drew A wrong. Either A or B, either A or F, and I know I drew F correct. Now I can continue on like this, but and just use my relationships the way I have it set up. But I want to draw this free body diagram correctly because I find the problem confusing otherwise. So we have A, we have B, and we have C. So our second attempt here is with A in the opposite direction now, B in this direction, and F in this direction. So we've drawn all our forces now correctly. Okay, so now if I sum forces in the y direction, set them equal to 0, I get B minus this F minus this A, or I could replace those, minus 2A, as we have it drawn here. So B equals 2A. Now, if that's the case, then if I draw, this is, say, the neutral position, let's look at the geometry of what's going on here. That means if A is pushing down, that means this spring is stretched. So this spring must, if it's stretching, it must be being pulled up by some delta to this point A, our new A up here. So it started out here and we stretched the spring from where the spring was attached down here somewhere. We stretched our spring up to the position where A is at. Now over here at B, we did the opposite because B is pulling up and B's pulling up twice as much as A, and they have the same K value. So B must be stretched twice as much as A in this direction. So this must be 2 delta. So this point we know now is our new point, and this point we know now is our new point. Both of these points are points on our beam. We can then draw a line through them. And let's actually get the line up here so it's straight. So we can draw a line through these, and it comes out here to C, which is 10 millimeters down, because that's where we hit the pad. Okay. So I can look at this and I can tell that, okay, this distance here must be, we can call it x, some distance x. That means this distance must be 50 minus x, since we know that the distance from here to the center is 50. Same with the distance from here to this point. It's also 50. So this is not really drawn to scale. At least the scales in the y and the x-axis aren't exactly the same. So anyways, let's look over here now. We see that we have a little triangle here. And I have x and a delta. And then I have a little triangle here. And these are similar triangles. Therefore, we can create a ratio. And if I'm looking for x, let's put that in the numerator. X over delta equals 50 minus x over 2 delta. Well, I can cancel delta out on both sides. And that means I end up with 2x equals 50 minus x, or x equals 50. Because I bring this over, it's going to be 3x over 3, which equals the calculator 16.67. Okay, great. Well, if that's the case, then I've got a lot of similar triangles going on here. I know this is 10. And now I know the distance from this point to this point. So I can use this triangle now and figure out what delta is. So then, delta over x equals 10 over, so this whole distance here is 100 minus x. 100 minus x. That's going to be the distance of this triangle now with the yellow outline. So delta equals 10x over 100 minus x, or 10 times 16.67 over 100 minus 16.67. And if you do the math here, this turns out to be 2 millimeters. Well, okay, great. That's delta. That's the distance we pulled our spring. So F equals delta times K equals, well, let's call this A, equals delta times K. So the force A is delta times K equals 2 times 10 to the minus 3 meters times 5 newtons per meter. So our meters cancel. We're going to end up in newtons. So 5 equals, so 10 times 10 to the minus 3 newtons equals 0.01 newtons. That equals A, which equals F, which is our answer, 0.01 newtons.